up until, and it has to be .com. And I have 10, but that's not working. What? Hi, welcome back to the channel. Why is SQL so difficult for me to understand? If you're new here, my name's Ash, I'm 27, I'm a cybersecurity enthusiast, and on this channel, we learn cybersecurity together through capture the flags and challenges. On today's video, we are going over the current event from TryHackMe, Advent of Cyber 2022, and we're up to day 17, the last part of the secure coding 3 days. For any other details that you need, like playlists, timestamps, or links, you can find them in the description below. Otherwise, let's get into the video. So I am on TryHackMe, day 17, secure coding. Gonna hit start machine. And as per usual, when I get stuck, I will be using Insider PhD's walkthrough, which you can find there. So it looks like our machine has just booted up the browser there, so that's great. So first section we have is introduction. So at this point, we are aware of some security concerns like input validation. So we've already gone over unrestricted file upload in day 15 and SQLI in day 16, but we're going to be looking at input validation in a more general sense before touching upon its most complex use cases, free-form text fields, followed by a quick discussion on how you may move forward in your secure coding journey beyond input validation. So next up, input validation foundations. So generally speaking, to validate input, we first need to know how a specific piece of data is going to be used in the rest of our application. So data goes through syntax and semantic validation checks to ensure that the user provided values are both proper in their syntax, following proper context, and logical. The value makes sense for the question. So if we just quickly go back to day 15, you cannot manually type your CV in the input field. The form asks you for a file that you need to upload, and you cannot just upload any file. It should follow a set of very specific rules, which we will be talking about in a later part in this task. So next section is HTML5 and regex. So HTML5 has a lot of built-in features that are going to help with input validation, which minimizes the need to use other languages like JavaScript. The input element specifically has an array of very helpful capabilities centered around form validation. For instance, this input type can be set specifically to filter for an email, a URL, or even a file. Among others, prompts checks whether or not the user provided input fits the type of data you're actually asking for in the form. And if it's not valid, it immediately returns to the user as a result. So there's even more control if we use regex or regular expressions, and this can be integrated into the mix. Simply use it with a pattern attribute in the input element. So we can see here we have a pattern of any lowercase or uppercase characters, any digits, and then a plus. Wait, what's plus? That's any character, any number of times. So is this just saying any characters, any number of times? And then for an email, it's just any character, any number of times. For TryHackMe, a literal .com. I've done a tiny bit of regex. So this is like a username excluding any symbols. This is only letters and numbers. So the first pattern of line code is easily one of the most fundamental regular expression patterns one can use. The instructions here to match any strings specifically composed for only letters and numbers and alphanumeric pattern that is case sensitive. The pattern on the second line is a bit more pointed in its instructions, specifying that an email can have any characters at the beginning as long as it ends with @tryhackme.com. Developing regular expressions can be very daunting as its nature is complex. However, its capability to match very specific patterns is what makes it special. Well-built regular expressions introduce a great way to immediately filter out user-provided input that doesn't fit the specific requirements that you have set. And I'm back. Just had a quick gym sesh. All right, now where were we? Regex 101. So let's go over some of the basics. So we've got our square brackets with some characters inside of them, and we can specify A-Z, which means anything lowercase in the English alphabet. If we want the vowels, we can go A-E-I-O-U inside brackets. If we want to match any of the set of characters regardless of case, we would do lowercase A-Z, uppercase A-Z, and if we wanted all lowercase plus numbers or alphanumeric, we would do it as follows. So there's also some regex operators. So the simplest one is the wildcard operator, denoted by a single period. This means regex will match any character. So it's quite powerful and used with the operators star plus, meaning min and min max. The asterisk or star operator is used if you don't care if the preceding token matches anything or not, while the plus operator is used if you want to make sure that it matches at least once. The curly brace operator, on the other hand, specifies the number of characters you want to match. Let's take a look at some examples. So to match a string, regardless of the size of the string, and only using uppercase or lowercase letters and numbers, we can use that. So if we want the first part of a string composed of letters, we can use the caret, specifies the start of a string. So that matches anything that's lowercase or uppercase alphabetical, denoted by the plus, means doesn't matter how many times that happens. And then the $ is the end of the character. So we want it to end in numbers. And I guess I still don't quite understand the star. That's a little confusing. The star, if you don't care if its preceding token matches anything or not. Oh, okay. So it's sort of like optional. So if there's numbers there, cool, match it. If there's not numbers there, don't quote me. If we want to match just lowercase letters that are between 3 and 9 characters, we can use curly braces and just have 3, 9. If we want a string that starts with 3 letters followed by any 3 characters, our pattern would be uppercase or lowercase 3 and then any character 3 times at the end. So there's also concepts of grouping and escaping, denoted by brackets and the right. So if we want to group things, we can put that. And if we want an actual dot, so like down here we have www dot, and we want a real dot, so we use this escape character. Yeah, so regex, like, it looks super confusing, but it's, when I've learned it, you just build it up little bit by little bit, and don't make a regex like super complicated from the beginning. So we've got a summary here that we'll definitely refer back to. So next section, the unique case of free-form text. So far we've looked at structured data, meaning we know how data is going to be sent and understood, but free-form text is more complex and not very straightforward because we don't really know what exactly is going to be. So structured data, for example, like a name, that won't consist of so structured data, for example, like a name, that won't consist of special characters like asterisks and whatnot. An age should only consist of like an absolute maximum of 3 characters. That makes sense. So then validation of those types of inputs can be done immediately. So again, free text is just a bit more complex and a bit more free-for-all. Validation checks just a little bit more limited and more challenging of securing because generally it's just more vague. So here's a couple things to keep in mind. Again, the question of how this piece of data is going to be processed by the rest of the application. Then what will be the context for which this freeform text field will be used. So maybe for blog posts are tackled very differently than text fields used for small comment sections or descriptive text fields. And thirdly, is free text field necessary for the business purposes in the first place? Could something else be implemented and achieve the same goal? So our best bet is through whitelisting, and there's an OWASP cheat sheet that we can link here, and it looks like we've got some things like validating a US zip code, validating US state selection from a drop-down menu, so that might come in handy. And the point of this is minimizing invalid characters, presenting through proper encoding, and whitelist expected characters and character sets. Next section, best remediation tactic. So for our next part, let's look at some simple base code below wherein a programmer attempts to retrieve the usual details from a user. So we have a HTML block of code. We have 5 inputs and a text area. So it looks like a basic form. Looking for the name, birthday, email, age, favorite website, and then just a general tell us more about yourself sort of area. So in this case, there's no input validation done at all. Let's fix up a bit and review it again. So it looks like they've added the type attribute, and that's detailing that we want text, we want a date, we want an email, a number, a URL in these input fields. So we can go a step further and we can include a required attribute, a minimum length, a maximum length, and a size. Same with the date, we can make that required, and we can actually set a minimum and maximum date entered. And like we saw earlier in this task, there is a pattern attribute which includes regex, and we can see that again condition in our inputs for our number and for our URL. So these are known as semantic checks. And this brings us to this last HTML tag, the text area. So this is our freeform text, and it's unique in such a way that applying syntax and semantic checks are pretty much impossible. So in order for us to really secure it, we need to define what content, example characters, character sets, symbols, etc. is acceptable, and then perform the actual whitelisting. Even then, it wouldn't be enough as it's still a very open field. And so techniques such as output escaping and using parameterized queries, among others, should be implemented as well. Next section, client side versus server side. So far we've been focusing on the pieces of data that we're getting from users, making sure it's just not garbage. So this is the client side of an application, and it is minimizing the attack surface. However, it doesn't actively cover malicious use cases. So output escaping and parameterized queries are implemented on this server side. So adding computational load to the server, but ultimately helping in securing the application as a whole. So we've got an example below using the built-in HTML entities PHP function to escape any character that can affect the application. So on the other hand, the one below uses HTML purifier library to help with some use cases, such as our text area conundrum above. So both examples are done on the server side to escape characters and purify content, respectively, both effective ways to prevent user misuse and XSS attacks. Implementing both client and server-side validations ensure that no stones are left unturned. This exact case highlights the importance of layering defenses and shows point blank the limitation of client-side input validation. It also gives rise to the notion that input validation is not a one-stop shop for securing your application. This HTML purifier library definitely makes less sense than this HTML entities. I'm pretty bad with PHP, so they're not either making that much sense. So next up, not all solutions are equal. So input validation is an important layer of security all production level applications should have. However, no matter how perfect your input validation is for your specific use case, there simply are limitations to all kinds of security implementations, and input validation is not exempt from it. So we can't make our application fully XSS proof through simple input validation alone. So in order to full XSS proofing, we need to require additional layers of defense, such as mitigation on the browser level via secure cookies, content security policy headers, and others. So next section, we have the summary. So despite being a very important security control, due diligence in securing apps involving user provided input not stop in validating the input per se. So there's a lot of other tools and frameworks out there into properly securing an application, as we went over HTML5's features for minimizing input from form misuse while using regular expressions. And we did take a look at regex, which is super duper hard. So as examples, they're not directly concerned about app security, but they do help minimize the attack surface of an application, and can be further tackled through server-side validation techniques, as we mentioned. So we shouldn't try and solve all security problems with input validation. There is not one control that could prevent persistent malicious actors, and so layering these controls is a better way moving forward. All right, exercise is the next section. So we've prepared a regex exercise that you can access through the machine provided. First, let's start the virtual machine by pressing the start button. At the top of the task, the machine will start in a split screen view. So while that's booting up, we've got to practice your regex first, change into the working directory regex practice folder using this command. Then you may either use egrep via the following syntax, egrep regex pattern here strings, or the regex checker.py script written for you via Python, either. We are aware that some structured data are more complex than others, so we have set a specific syntax you may follow to make the exercise simpler. Have fun. Okay, cool. This is definitely going to stretch my brain. So we've got our questions here. Let's just quickly go over these last points. We've got filtering for usernames, alpha, numeric, minimum of 6 characters, maximum of 12 characters, may consist of upper and lower case letters. And this is going to tie in with filtering for usernames. All right, let's go show split view. All right, so open up our terminal. So we'll cd into the desktop and the regex practice and we'll have a look what's in here. So we have a regex checker.py. Like it said, we can run Python through that. So we used an alphanumeric like such. So capital A's to Z, lowercase, and then numbers. Then we want a minimum of 6 characters. So I think we can use the curly braces for this. I'm not sure if we need to go like 0 to 6 or it's just 6. If we look back at our example, we had 3 letters followed by any 3 characters. So we just used the curly braces with the number. So that should work. But there's a maximum of 12 characters. So we do need to add a comma. 6 to 12 may consist of upper and lower case letters. I think I've already covered that with alphanumeric. So let's then run that against the strings file and did not work. I think I missed the plus operator. Oh wait, we're supposed to still use, I remember when I first actually used, I don't even know how to use the caret. Right, so I'm missing the caret and the dollar sign. Wait, is the output, the hell? Are these the highlighted output? I was looking at the red. Then I'm looking at 1, 2, 3, 4, 5, 6 usernames in white. No. All right, I think the plus was actually doing my head in. 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool. So the plus was doing this unlimited times. That's why I was getting the funky output. I didn't need that. So filtering for usernames, one username consists of a readable word concatenated with a number. What is it? Do I have to build a string for that? Or I can just type in user35 because I can see it. Just out of interest, can I do this? So my thinking here is to add brackets around this first regex expression, brackets in the next, so these are the groups, and then build out one specifically to find user. So find A to Z, uppercase or lowercase, 4 times, because it consists of a readable word concatenated with a number. I know what it is. And then we want to find 0 to 9 followed by 2. All right, that didn't work. I'm not going to try. I don't know. So next up, we've got filtering for emails. How many emails fit this syntax above? So we've got filtering for emails, follow the form local-part at domain without quotation marks. Local-part is a random string and the domain is in the form of domain name.ld, all top level domains tld are.com. So our egrep is going to be looking for something beginning at the start. So a random string, I think alphanumeric would be okay because we can have numbers and email addresses. So that as many times as they want, followed by the at symbol, literally, the domain is going to be the literal domain, like the word domain, followed by a literal.com. All right, let's try that. Didn't find anything. I've realized I used 2 different escape characters. They should be /. Still didn't find it. All right, let's just start over. So that's going to find the first character. Now we have the plus. That's going to find any of those characters up until a special character. So then we want an escape character that's looking for the at. So now I have used the right escape character. We've got that at, and then we want to find anything. Oh, okay. So we're not actually supposed to use domain literally. It's just any domain name. So again, it should be lowercase though. Actually, shouldn't it all be lowercase? We can have numbers in a domain name, but then it should be literal.com. See, if I just go slower, I can find it. 1, 2, 3, 4, 5, 6, 7, 8. How many emails fit the syntax? There's more than 8. Oh dear. Maybe there are some capitals. Oh, we are allowed. If we look back at our example for this, there was nothing about emails, but we could have other characters. It doesn't have to be. Could I just go dot plus, meaning any character any number of times, and the same for after? So any number of characters any number of times, at any number of characters any number of times, .com. Okay, so now we're seeing some more results that we were filtering out. Okay, now we have 11. So I was actually limiting the emails that could get passed in. So next, filtering for emails, how many unique domains are there? So I'm just going to put this into a domains .txt file. So now we can just grab this file. I was trying to achieve multiple regex, but I'm just going to do it this way. So we've got our list of domains there. And now let's write another expression. And this time we want to know how many unique, how the heck do we do that? So we're not starting from the beginning this time. So if it matches at anything, any number of times, literal.com. All right, so that is indeed finding the domain. How do we filter out unique? I mean, I can just count them, but that's not going to scale up very well. After counting, I counted 8. I don't know how to filter out to find the unique domains from there. Am I supposed to do a regex? How do I do a regex for that? Filtering for emails. Next, what is the domain name of the email with the local part lewisham44, so amg.com. Filtering for emails, what is the domain of the email with the local part maximax? So we have fedfull.com. Filtering for emails, what is the local part of the email with the domain name hotmail.com? So we had this one here, hushin.volts. So next we got filtering for URLs. How many URLs fit the syntax provided? So we'll go back up to our syntax here. All right, so starts with either HTTP or HTTPS. So let's start with that. So in the beginning, we want HTTP. I think we used the pipe for HTTPS. So either HTTP or HTTP, I think. Let's just run that. Then some of the URLs have www and a TLD should exist. So we can see some here don't have like .com or .net or something. So let's fix that. So from there, we can have any number of character. Okay, so we should be able to go dot plus. So from there, any number of character, any number of times. And then the end should finish with a literal dot and then a top level TLD is .com again. So that didn't work because some .coms don't actually end, like they're not actually at the end of the string. So if we just remove that, so we only want these results. We're still picking up everything else. Okay, so I've got 17 in total and that's not right. So we need to work on this expression. So should we group our HTTP and HTTPS first? Okay, so we need to actually group this together. Now we actually get some right results. So now we have, and that's still not right. Let's just remove the end and we'll go back to our original list. Oh, okay, so we can achieve the same thing if we just put a question mark next to the character. So I just put the question mark next to the character S, and that still gives us the same output if it's HTTP or HTTPS. All right, I'm not sure how exact I need to be here. So we can have www or not. So I'll group that together. All right, so that's working so far. This string is already looking crazy, but all it is just the colons, whack, whack, but just with escape characters in the middle. So that's picking all that up. So that's good. We're then getting the www or not. Then we want the actual top level domain, which can be any character as many times as it wants, up until, and it has to be .com. And I have 10, but that's not working. What? An optional character / set of characters may be matched by putting after them. Characters can be grouped by putting them inside parentheses. And I'm getting it. Filtering the URLs starts with either HTTP or HTTPS. Some URLs have www and a TLD should exist, which we learned all top level domains are .com. Now I saw .net though. Are there other, can we go like, maybe it's .net or that way, literal.net or .com? All right, so that put an extra 2 on the list and that still ain't right. Okay, so this is the correct string. I'm not gonna lie, I looked at the walkthrough because I was getting a little frustrated and dinner is ready from my dear wife who is waiting on me. So lastly, we just have how many we've got starting with HTTPS and we have got 7. And that's going to finish us for day 17. Thank you so much for watching until this part of the video. I do really appreciate it. Feel free to like, comment, and subscribe, all that good stuff. I really appreciate it and I appreciate you. I'm going to let YouTube recommend a video up on the screen for you, plus the playlist to everything else in this series. Otherwise, I'll see you in the next video. I gotta go eat. See you later.